So to divide this, we're going to divide this piece, and then we divide this piece. So we have to take this, because this problem could be rewritten. We're not going to take the time to rewrite it, but it could be rewritten as the first term over 3 minus, yes, the second term over 3. I mean, you could take the time to break it into terms, but it also means the same thing because their denominators, their division problems are the same, so we just combine it into one problem. But they mean the same thing. So the solution, the simplification, 3x squared divided by 3, 3x squared divided by 3 is x squared because 3 divided by 3 and there are no exponents to change. And then negative 6x divided by 3 is minus 2x. So you have, sometimes the denominator disappears, right? Other times, if your problem's a little more complex, so let's say it's, let's go, 16x to the third y squared plus 4x to the third y over 2 xy to the third. Again, you could rewrite it into the two problems. If there was a 3-term, right, you could write it into 3 problems. Or you can just acknowledge that there are going to be 2 elements. This is Molly. Uh-huh. Yes, it was in my room. He got it in Miss Driscoll's room. Yep. Bye-bye. All right, so we're going to simplify. 16x to the third y squared, right? Over 2xy to the third. So that's 8, right? 16 divided by 2 is 8. Leaves me with an x squared in the numerator and a y in the denominator. Do you agree? Yes. Then I'm going to do the next one. 4 divided by 2 is 2. X to the third, x leaves me with x squared in the numerator, right? Oh, I forgot. Oh no, I'm okay. And y squared in the denominator. Can I combine these together? No, these would have to stay separate. And why would they have to stay separate?
Because the y squared.
Right. Because my numerators are okay, right?
Yeah.
But the denominators are different, so they're not problems that you can combine. Let's do, I want to get a example that works.
What's our answer?
Huh?
That is the answer, yes.
Oh, Miss Lum,
Yes.
the denominator was the same. Could we combine?
If it was ended up with a denominator the same, yes, you could combine it. Let's do Let's do one more that works and one more that doesn't work, and then you can start your homework. Deal? Okay. Let's do this one. 16x to the 6th minus 12x to the 4th plus 4x squared over 4x squared. So again, this is a trinomial, so we have to do 3 problems, yes? Okay. 16x to the 6th divided by 4x squared is 4x to the 4th. 16 divided by 4 is 4. 6 minus 2 is 4. Yes? Then I have negative 12 divided by 4 is negative 3. And x to the 4th divided by x squared, x squared. Then I have 4 divided by 4 is 1. X squared and x squared.
0.
2 minus 2 is 0. X to the 0 power is 1, so
1.
1. Blammo. And one more. What do we think? What do we think, guys? Woo. Let's do, ooh, this one's fun. 15x to the 5th minus 25x to the 3rd plus 5x squared over 5x to the 4th. So again, trinomial, so I'm going to have 3 answers. $15 divided by 5 is 3. X to the 5th divided by x to the 4th is x to the 1st, so just x. Negative 25 divided by 5 is x to the 3rd divided by x to the 4th.
Don't you subtract it?
What's 3 minus 4?
-1.
Negative 1, so it goes to the denominator. 5 divided by 5 is x squared divided by x to the 4th is x to the negative 2, right? So that goes to the denominator.